Welcome viewers. In this video we will see the losses and efficiency of a DC generator. Subscribe this channel for more videos. The soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. So first we'll see the efficiency. The efficiency of DC machine is the ratio of the output to the input. So the DC machine is nothing but it can be act as either generator or motor. Both are same, construction wise there is no difference, so that is given as a DC machine. So the efficiency is nothing but output power divided by the input power. What is the power we are getting and what is the power given to the machine? So that ratio will give the efficiency. The whole amount of input energy to the DC machine is not available at the output. The input what is given to the DC machine not available at the output. Why? Because of various losses takes place in the machine during the process of electromechanical energy conversion, right? The input given is not exactly available at the output. In between some losses will occur, right? So that we can write input equal to output plus losses. The input what we are giving, so it is converted into output plus some of the losses. By adding the output and losses we will get the input. So what are the losses available in the DC machines? One is the copper loss, because we are having the windings, copper windings are available. So the losses takes place in the copper coil, and we have the core is available, magnetic core is there. So the loss available in the core is nothing but a iron loss or core loss or magnetic loss, right? The core is there and winding is there. The loss available in the winding is a copper loss. Loss available in the core is nothing but a core loss or iron loss or magnetic loss. Then we have mechanical losses also available. Due to friction and vintage, some losses will occur, that is called a mechanical loss. Now we will go to the copper loss. So the copper loss means loss happened due to the copper coil. The loss takes place due to the current flowing through the winding is called a copper loss. The winding is available in the three different places, either armature copper loss. The winding is available in the armature and as well as field. The winding is available both in armature as well as field. So the loss occur in the armature is called a armature copper loss, Ia square into Ra. The loss available in the shunt field copper is nothing but shunt field copper loss, ISH square into RSH. The loss in the series field is called a series field copper loss, ISC into RS, ISC square into RS, right? So the copper available in both rotating part as well as stationary part, so that it is called a three different type, either armature copper loss or shunt field copper loss or series field copper loss. Then we will go to the iron loss. So the iron loss is due to the loss in the core. So these losses include hysteresis losses and eddy current loss. There are due to the rotation of the iron core of the armature in the magnetic flux of the field pole. These losses are almost constant. The previous losses, this copper loss, when the current increases, the losses also increases. If the armature current increases, the losses will increase. So this depends upon the current, so that it is a variable loss. The current increase means the loss will also increase, but this is the constant loss, almost constant. It will not change with respect to the current. Now we will see what is the hysteresis loss and eddy current loss. So hysteresis loss, this is due to the reversal of magnetization of the armature core. Every portion of rotating core passes under N pole and S pole alternatively, thereby attaining N and S polarity respectively. The core undergoes one complete cycle of magnetic reversal after passing under one pair of pole. So in order to rotate, we are creating N pole and S pole alternatively. The winding connections are given in such a way that it will create N pole, next by S pole alternatively it will create. So this reversal of magnetization, due to the reversal of magnetization, the losses occur, that is called a hysteresis losses, that is given by this B power 1.6 max F into V. F is the frequency and that V is the velocity, right. So, this is the formula for a hysteresis loss. Then we will go to the eddy current loss. When armature core rotates, it cuts the magnetic flux. The armature winding, actually armature winding should cut the magnetic flux, but armature windings are placed in the core. So, the core also cut the magnetic flux. So, due to that EMF is induced in the body of the core. Normally what we need is the EMF should be induced in the armature winding, but armature winding is placed in the armature core. So, in that core also cut the magnetic flux and EMF also induced in the core, which cause the current to circulate in the body of the core, which is called a eddy current, right. The EMF induced in the core of the core, due to that current circulate, that is called a eddy current. The loss due to the flow of this current is called a eddy current loss. It is K into B max square F square T square into V square, right. So, this is the magnetic field intensity, magnetic flux density, frequency, thickness and velocity, right. So, these two losses due to magnetic reversal as well as the EMF induced in the core. Now, we will go to the third type, mechanical loss. So, due to friction and windage, some losses will occur, that is called a mechanical loss. Friction means due to the friction, windage is nothing but the force between the rotor and air, right. This is called a mechanical loss. So, these loss also almost constant, it will not vary with the current, right. So, that stray loss, we have one more term, the magnetic and mechanical losses together is called a stray loss, because these two are constant. Mechanical loss also constant, magnetic loss also constant. So, by adding these two, given the new name stray loss. Now, we will go to the next one. Further, we have constant loss and variable loss. Again, it is split into two major divisions. Constant loss. What is constant loss? The shunt and compound machine where the field winding is constant. The shunt field winding copper loss is also constant. If it is series field, means when the current increases, the losses will increases. But in the shunt field, the current is almost same. The current will not increase, depends upon the load. So, the shunt field copper loss also we can take it as a constant loss, right. So, already we have constant losses available. This is called a stray loss, that is the sum of magnetic loss and mechanical loss. So, the stray loss along with the shunt field copper loss is called a constant loss or standing loss, right. So, the stray loss already we discussed, the sum of mechanical and magnetic loss. If you add the shunt field copper loss, because it is also almost constant, by adding these two we can take it as constant loss or standing loss. These losses are independent of the current. Then what about the variable loss? As the load increases, the armature current also increases, varies. The armature current is depends on the load. So, the armature copper loss vary with the load. Therefore, armature copper loss is called a variable loss, right. Either the armature winding or series field winding, when the load increases, armature current also increases, so that the losses also will increase, that is armature copper loss, right. So, the total loss is nothing but constant loss plus variable loss. The constant loss is taken as WC, variable loss is IA square into RA, right. The loss due to the armature winding, sum of these two is the total loss, WC plus IA square into RA. So, in this video we discuss about the efficiency. In that efficiency, losses is the very important thing. The losses also we discuss majorly three types: copper loss, iron loss and mechanical loss, right. Again further we classified into constant loss and variable loss, right. Subscribe this channel for more videos. The link is available in the description box for other videos and the course material. Thank you. Welcome viewers. In this video we will see the power stages of a DC motor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Now we will go to the topic, power stages of a DC motor. Before going to the power stages, we see the losses. What are the losses available in the generator or motor? Both are same. So we have three different losses available: copper loss, magnetic loss and mechanical loss. Now we'll see these losses in detail. So the losses takes place in the DC machine. DC machine mean it can be used as either motor or generator. Copper loss, iron loss or core loss or magnetic loss, then the mechanical loss. First we will see the copper loss. The loss takes place due to the current flowing through the winding is called the copper loss. That is the winding available in three different places. That is one armature, either armature copper loss, Ia square into Ra, and field winding. It may be series field or shunt field. So shunt field copper loss, ISH square into RSH. Similarly, series field copper loss, ISC square into RSC. The loss due to the winding of is nothing but a copper loss, because windings are made up of copper. That copper available in armature as well as field. Field may be series field or shunt field. Then iron loss, core loss or magnetic loss. The losses include the hysteresis loss and eddy current loss. These losses are due to the rotation of iron core, because due to that it is called a iron loss or core loss. Iron core of the armature in the magnetic flux of the field poles. These losses are almost constant. Now we will see what is eddy current loss and what is hysteresis loss. So hysteresis loss, this is due to reversal of magnetization of the armature core. Every portion of the rotating core passes under N pole and S pole alternatively, thereby attaining N and S polarity respectively. The core undergoes one complete cycle of magnetic reversal after passing under one pair of pole. So this loss due to the reversal. N pole and S pole is alternatively we are making the arrangement to, in order to get the attraction and repulsion, then N pole and S poles are alternatively produced. So due to this reversal, the reversal of magnetization of the armature core, the loss happened, that is called a hysteresis loss. It is nothing but it is B power 1.6, B max power 1.6 F into V. So formula for the hysteresis loss. Then we will see the eddy current loss. When the armature core rotates, it cuts the magnetic flux. Hence EMF is induced in the body of the core. Right? This armature conductor, armature while rotating, it cuts the flux. Actually, the field coil should cut the flux, armature conductor, but core also cuts the magnetic flux. So due to that, EMF is generated. So which cause a current to circulate in the body of the core. So that current is called eddy current. So due to that eddy current, some losses will happen. So this is a formula for the eddy current. So these two are due to the iron core. These two losses due to iron core. Then third one is the mechanical loss. Friction loss or vintage loss. This is due to the almost constant. These losses are almost constant. So the armature, first one copper loss, second one iron loss, third one mechanical loss. The second and third is almost constant. Iron loss and mechanical loss are constant. Accordingly, one more classification available. Stray loss. The magnetic and mechanical losses together is called a stray loss. Magnetic loss and mechanical loss together is called as a stray loss. Now we will go for further classification. So we have one more constant loss. For example, shunt field, shunt and compound machine where the field current is constant. The shunt field copper loss is almost constant. Only very less amount of current is flowing through the shunt field winding. But in series field winding, full current is flowing. But in shunt field, only less amount of current is flowing. It is not also varying. So the stray loss along with the shunt copper loss is called a constant loss or standing loss. It will not vary with the load. So that stray loss, that is nothing but magnetic loss and mechanical loss. By adding shunt field copper loss, we can take it as a constant loss or a standing loss. Then we have variable loss available. Similar to the constant loss, we have variable loss. As the load increases, the armature current varies. The armature current is independent of the load, is dependent on the load. So, the armature copper loss varies with the load because Ia square Ra. If armature current increases, the loss will also increases. So, this depend upon the load. Therefore, armature copper loss is called a variable loss. All other losses are constant loss, right. So, that variable loss equal to armature copper loss. So, the total loss is nothing but constant loss plus variable loss, that is Wc plus Ia square into Ra. This is the constant loss and this one variable loss. Now, we will go to the power stage. So, here one more condition is given. Condition for maximum power developed is nothing but back EMF equal to V divided by 2, applied voltage divided by 2. So, that will give the maximum power developed. Back EMF is created in the motor, that should be equal to half of the applied voltage. Then we will get the maximum power developed. Similarly, the condition for maximum efficiency is armature copper loss equal to constant loss. This is nothing but variable loss, that is variable loss equal to constant loss. Just now we discussed what is variable loss, what is constant loss. If both are equal, we will get the maximum efficiency. Now, we will go to the power stages. So, the input to the motor is nothing but a electrical energy. Motor input is nothing but V into IL. Voltage is applied to the motor. Motor means the electrical energy is converted into mechanical energy. So, the input to the motor is the applied voltage V into IL. Power is V into IL. So, immediately there is a armature copper loss will happen. The copper loss. With this applied voltage, some amount will be lost due to copper. Remaining will be power developed in the armature, EB into Ia, right. Some part will be lost due to copper loss, the remaining will be available in the power developed in the armature. So, then the motor will start rotate, right. When it is rotate, the rotational losses will happen, it is called a mechanical loss. The remaining is available as a motor output. So, the electrical energy is given. So, the field is, the current is flowing through the field winding and armature winding. So, some copper loss will happen and power is developed in the armature, so that it start rotates. Once rotated, the rotational losses will happen, remaining will be available as a motor output. Motor output is nothing but rotation. So, based on that, we have three different efficiencies available. Electrical efficiency, nothing but EBIA, output divided by input, EBIA divided by V into IL. This is applied voltage, this is the power developed in the armature, EBIA divided by V into IL. Then mechanical efficiency is nothing but motor output divided by EB into Ia. This is the power developed in the armature, this is what is the motor output we are getting. So, the overall efficiency is nothing but motor output divided by motor input. Motor input is V into IL. So, these are all three different efficiencies available. Now, we will see the diagram so that you are able to understand. So, the output divided by input, EBIA divided by V into IL is nothing but electrical energy, electrical efficiency. Motor output divided by this power developed, EB into Ia, that is called a mechanical efficiency. So, the motor output divided by motor input is nothing but the overall efficiency. So, in this video we discuss about the power stages of a DC motor. Along with that, we discuss about the losses. What are the losses available? Primarily there are three losses: copper loss, iron loss and mechanical loss. Copper loss means loss happened due to the copper winding. The windings are made up of copper. So, the copper winding available in three places: armature copper loss, shunt field copper loss and series field copper loss. Then second one is the iron loss due to the iron core. There is two losses available: hysteresis loss and eddy current loss. Then the last one is the mechanical loss. Due to friction and windage, some losses will happen. Then again we have stray loss. Mechanical and magnetic loss together is called a stray loss. With that, if you add the shunt field copper loss, the shunt field copper loss is independent of the load. If you add that, that is called a constant loss. then variable loss is nothing but armature copper loss. The armature copper loss will vary according to the load increases. If the load increases, armature current will increase, so armature copper loss also increases, so that it is called a variable loss. So total loss is nothing but constant loss plus variable loss. Same thing can be used for the condition for maximum efficiency is constant loss equal to variable loss. So based on that, we can see the power stages, what are the stages the losses will happen, and also we can see the efficiencies, electrical efficiency, mechanical efficiency, and the overall efficiency. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening.